Welcome everyone to the non-interpretive skills session, part of the Essentials course. My name is Mark Coley. I'm the Director of Clinical Informatics from UCSF, and my title of my talk today is Informatics, What is it and why should you care about it? So in preparing for this talk, I do this all the time, so I don't really have a definition that I carry around in my head, so I did what I think everyone does, and they go to Google and they type something in and they see what comes up. So when I went to Google and I typed in informatics, this is the definition, the science of processing data for storage and retrieval. And I started to think about this, and it's a nice, elegant definition. It's really short, and I think it's really important because a lot of times we think about one piece of this. We think about storage or we think about retrieval, but we don't really think about both at the same time. And this is evidenced in our enterprise imaging workflow everywhere. If you go and find places where there's burning patients' images onto CDs and stuffing them under a desk in the corner, they're really thinking about storage, but they're completely neglecting retrieval. So I like this. The definition that I would create if I were going to talk about this and tell people what I do, I'd say that my job is making people's lives better with technology. So making it easier for people to do their work, making it easier for people to do better work. That's really informatics to me. One other thing that's important is to know what informatics isn't. And informatics is not the same as information technology. Informatics folks need to work with very closely their information technology colleagues, but those are the people who are going to run all of the servers and the networks and the storage and make sure that things are, that the lights are still on. So another one is, I forgot my password. Informatics or IT? IT, right? You're going to call the IT help desk. You're not going to call me. Your monitor breaks, the server shuts down. That's all IT. So just to give an example, and I'm sure we're going to hear about this more from Dr. Strong, an informatics specialist is quite helpful if you're going to add new teleradiology business to your practice and you want to figure out how you're going to get images from the outside hospital, into your PAC system, so that you don't have the nightmare scenario where one radiologist has to have 3 different workstations and roll back and forth, and they've got different logins on all of them and they're all timing out and it's terrible. And then in order to be able to take reports and return them back to the outside hospital, the informatics radiologists really have the knowledge that it takes to do this type of work in a very streamlined fashion so that we can maintain people's job quality and efficiency. Another example of what informatics specialists do is to help give people advice on things like structured reporting. There are a lot of ways to make structured reporting terrible. radreport.org has a lot of great structured reporting templates, and there are also some articles out there that talk about checklists. What are the things that you should be thinking about when you're designing a good structured report template? A lot of people use these RSNA templates as a starting point, but then they make their own customizations. And you want to have someone who has some experience with this so that they're not making customizations that are making things less efficient or they're making them harder to use. And then other pieces of structured reporting, getting really excited about the new radelement.org. This is really going to help us take and transform our free text reports into truly discrete data elements that can be represented in the EMR. So an example of that is, wouldn't it be really great if you could just run a report in your EMR and show you all of your patients who had LIRADS-5 lesions? Today we can maybe do that with some natural language processing, but wouldn't it be really great if we just absolutely knew that we were getting the right data? And that's what we're starting to work on with things like the common data elements. Another piece of this is decision support. So this is a picture of a presentation, and it's actually a screenshot of a tweet from an earlier presentation. And basically it's showing you these criteria for ovarian cysts on all these different modalities. And there's no way in the world that I can remember this. So we need to have better tools so that when I'm interpreting a study and I run across an incidental finding, that I can say, okay, there's a 4-centimeter ovarian cyst, and the system already knows the patient's age and automatically puts in the right recommendation. Because even if you think you remember all of these things, all of the data and studies show that we're really terrible at actually adhering to these guidelines. So we're creating computerized systems that are going to help us be better radiologists. Paul Chang is going to talk some more about analytics, so I'm not going to really dive into it here, but business intelligence and analytics is also something that the informatics specialist can help you out with. And really, many of us are probably used to static reports, but moving beyond static reports to business intelligence tools and platforms that really help you drive people towards self-serve decision making, where the people who are making decisions can actually look at the data and slice the data and dice the data to answer their questions in a much more quick, iterative fashion. That's one thing that informatics folks can help you with in your practice. So why else should you care about this? If those use cases aren't really resonating with you, what other things do I think you need to pay attention? Well, we've been really lucky, and if you went to the opening session, you heard Bob Wachter talk many times about how radiology has really been in the forefront of creating digital information in healthcare. I mean, we've been having digital modalities since the mid-70s, and now there are even more things that are stacked on top of this figure. It's even a little bit old, even though I think it was published about it a year or two ago. Now you'd stack machine learning and a few other things on top of here. So the really important one here, though, is this one, the EHR. And the fact is that, you know, our healthcare enterprise has a relatively fixed pot of dollars that is increasing slowly, but the share of that fixed pot of dollars that goes towards information technology has just been growing tremendously with meaningful use and implementation of the EMR. So back in 2014, they said the EMR market had surpassed $23 billion. And in 2015, Partners released a statement that said that their EHR implementation was going to cost them $1.2 billion with a B, billion dollars. So the really important part about this is that we're spending more and more on healthcare IT, and radiology in the past was kind of on its own. So if there was a pot of healthcare IT dollars, we had a very large share of that. Now, if you don't have an informatics specialist at your institution to have a seat at the table, you're really at risk of losing out on your share of those healthcare IT dollars. So I would argue that in order to continue to be relevant in this massive financial world, we need to make sure that we have people who have a seat at the table. The other reason why informatics specialists are important is we need guides, especially in this time of machine learning. There's a ton of hype out there, there's a ton of anxiety, and we need thought leaders who are going to be able to guide and shepherd us through this project. And those are folks like Keith Dreyer and Brad Erickson and Elliot Siegel and, of course, Paul Chang. So I think that we really need to care about this. There's a lot of hype and there's a lot of anxiety, but if we look towards our leaders and what they're saying, I think that we're going to be all right. Another thing, getting a little bit more specific, if you haven't heard of the Protecting Access to Medicare Act or of 2014, this is probably the number one thing that you need to go home and look up, because this is a requirement that ordering providers for outpatient and ambulatory imaging studies consult a decision support system when ordering CT, MR, and nuclear medicine studies. And this is essentially putting a roadblock on the front door of our business. So this is something that you need to be critically involved in, and there are some software products that the different vendors are offering in order to help support this process. But this is a critically important project, and is going to really require you to engage not only the informatics specialists in your radiology department, but also to have those folks interface with the referring providers so that you make sure that they have a seamless experience when they're bringing business to you. So this is just another slide talking about the PAMA. They're starting out with what they call claims-based reporting. So essentially, Medicare is going to deny claims that don't have a score associated with them. They say they're going to start no sooner than January 2018. This may be a little bit of a moving target, but I wouldn't treat it as such. And eventually, they say that they're going to look for outlying ordering providers and give them feedback on how they should improve their ordering skills. So this is going to dramatically change the way that people order imaging studies. Another thing that's dramatically changing our world and increasing the need of having an informatics specialist in your practice are things like the lung cancer screening registry. So in order to bill for Medicare patients for CT lung cancer screening, you actually have to participate in a registry, which sounds like a great idea. It's fabulous. It's the right thing for patients. It'll help us drive towards measuring outcomes and not just measuring diagnostic rates. But this is the devil's in the details here. So in order to participate in the ACR lung cancer screening registry, there are 83 unique fields. Not all of these fields are actually required, but only 17 of these fields come from imaging data, so things that are incorporated in that DICOM header. 12 more of these come from traditional order data or are generated by the radiologist at the time of the report, and the remainder of these blue boxes are essentially pieces of data that come from the EMR. And the challenge with this is that we're typically used to drawing data out of the PACS. We're real good at that. We're real good at drawing the data out of the radiology information system. But as radiologists, we're not all that great at drawing this kind of data out of the EMR. And some of the things are things that we're not really used to handling, like social security numbers, education level, and radon exposure. So if you don't have somebody in your practice who really knows where this data sits and how to get it, you're going to struggle in providing the service. Or you're going to spend a lot of money buying a vendor-based solution, and you're going to spend a ton of money getting your IT folks at your institution to implement it. So who are these informatics specialists that I'm talking about? They're people that have dedicated training or experience. They usually have somewhere between a day to half a week worth of protected time per week. They usually report to the radiology chair or the CMIO or CHIO or CIO in your institution. I firmly believe that they need to do clinical work because that's the only way that they can continue to be relevant and have a voice when it comes to the workflow and understand the solutions that they're supporting and really be that bridge person between IT and the clinical practice. I put board certified plus minus here. There's a fairly new certification in clinical informatics, and that's really, I think, directed more towards the EHR and kind of the larger practice of health informatics, but the jury's still out on that. All right, so this sounds pretty expensive, right? Half an FTE. That's a big investment. What can I do to recoup some of that? So I'm just going to tell you about an example of how I replaced one of these and how I saved money. So this is a fax machine, and we were doing some teleradiology business where the outside hospital would send images into our teleradiology packs. That would automatically trigger creation of an order and send it into our dictation system. The radiologist would read the study, generate the prelim, and dictate a report. The film assistant in the reading room, in the midst of answering all the phone calls and calling people and getting a hold of everyone, it was their job to monitor this queue to see when the radiologist had actually reported the study. And they had lots of different queues that they were trying to monitor, and they're all in disparate systems, and things easily slip through the cracks all the time. Once the assistant found that, they would actually print out the report and then turn around and stick that in a fax machine to send that to an outside emergency room. And this is terrible. I mean, there's just so many places where this can slip through the cracks. And so I helped design and had my team implement a workflow solution where we just basically eliminated part of we eliminated the assistant out of the workflow. So we had the study sent into our teleradiology packs. That order was still created and sent to dictation. The radiologist read the study and dictated a report, but instead of having the assistant in the loop, we used an interface engine to automatically generate a fax and send it out to the outside emergency room. So what happened? How do we measure our ROI for this? And the big thing is that we decreased our turnaround time by 13 minutes. And that may not seem like much, but this was overnight emergency room business where we were contractually obligated to do this work in 60 minutes or less. And when all those things were slipping through the cracks, I mean, we were bumping up against that ceiling all the time. So being able to drop that turnaround time by 13 minutes gave all of our radiologists more time to spend what they're supposed to be doing, which is looking at the films. And, you know, we estimated how much time the film assistants saved by removing this task. It's not a huge dollar amount, but it did allow them to focus on other more customer-facing activities. And then, of course, the ED satisfaction went way up because they were getting their results consistently more quickly. Can you afford one of us? Can you afford an informatics specialist? And why don't you just hire a programmer, or why don't you just hire another PACS administrator? So this is my little back-in-the-napkin math example, and you can probably tear it apart if you'd like, but if you have a 40 radiologist practice and they all work 9-hour days, that's roughly 540 minutes per day. If your informatics specialist consistently saves each radiologist just 5 minutes a day, that means you're going to spend, over those 40 people, 200 minutes, which essentially is about a 0.4 FTE. So if you really have someone who understands where you can find these little efficiencies, even just small efficiencies like 5 minutes, the investments, that time they're going to pay for themselves quickly. The other thing that informatics specialists do is innovate. So one of the things that I helped develop in our practice was a biopsy follow-up tool. So we would receive radiology reports, and we also had a feed of the pathology reports. And so I did a lot of procedures, and I would just log into the system and essentially be presented with a list of my patients who I'd biopsied, and I could tell at a glance which patients their pathology had already come back for. I didn't have to go and log into the EMR. I didn't have to go and type in their medical record number and see whether the path was back or not. I could easily see whether it was back. And when I click on it, I could actually see both reports side by side, and I could flag whether or not the pathology was concordant or adequate. And then, you know, we could alert doctors and physicians if we felt like maybe we missed the lesion. And, you know, that's dramatically important if a lesion is very suspicious, but the biopsy comes back normal, and the outside provider may not know that it really should, we just missed it. Not that it's actually truly normal, but we just missed the lesion. So this has a big impact in our practice. The other piece about this is that you can use this data if you're looking at turf battles. So if someone comes and says, you know, the XYZ non-radiology department is going to start doing all these biopsies, and you say, hey, here's my concordance rate, where's your data? They don't have it. So this is one way to protect and maintain your turf. This is also a nice objective way when that one, not that this has ever happened to me, but when the transplant surgeon comes back and says, why did you not get any glomeruli on that kidney biopsy? And I say, well, I've done 300 kidney biopsies, and this is the first one that's ever happened on. That is a much different conversation. So things like this can really be quite helpful. Just wanted to highlight some of the work that's been done at the University of Pennsylvania. This is a patient-oriented reporting system, essentially a way that we could use informatics tools to make our radiology reports more accessible to lay people. This is actually presented as an education exhibit here as well and published in JDI. So this is an example from their demo, and essentially you have a radiology report that has all of these different terms highlighted, and then this other pane over here that essentially gives you context sensitivity and starts out with kind of an overview, but as the patient looks at or clicks on some of these terms, the diagrams that are displayed update and can be indicated in real time, trying to give the patient a little bit more understanding about what's going on. The other cool thing that they did with this is rather than create each one of these pieces of content from scratch, they actually leveraged web APIs to do things like search Wikipedia for these terms. So instead of having to go in and type definitions for all these things, they could easily link out to existing resources. So, and this is just another example of that. I just have two more things to tell you. One thing is what I call the 90-10 rule. And this is that everybody comes to me with a piece of technology and expects it to fix a problem in the workplace. And the fact is that every single informatics project is really about 90% about humans and culture and the way that they're going to interact with that system. And if you don't address those cultural issues when you're trying to implement a piece of technology, you're completely destined to fail. I think this is probably the most important thing that I repeat constantly in my job. So, said differently, new technology without cultural change and without thinking about adoption rarely fixes your problems. In summary, I think that informatics specialists are about making people's lives better with technologists. It's important for us to be in place in your organization so we can help maintain our seat at the enterprise table with the EMR to improve efficiency. I think that we pay for ourselves, and we also can bring innovation into our workplace. And with that, I'd like to thank you.
Hi, good morning. I'm Paul Chang from the University of Chicago, and I'm going to apologize due to my negligence. I did not realize I had 20 minutes. So I'm going to try to squeeze a 40-minute talk into 20 minutes. Now, for those of you who know, that's very hard for me because I don't speak very quickly, but I'm going to try. So what we're going to talk about, they asked me to talk about business intelligence analytics, which is one of my favorite subjects, because like anything, I like to take contrarian positions about stuff. Now, the motivation, obviously, as we know, how many of you are sick of this, volume versus value? We get this, right? In other words, the rules of the game have changed. And so now it's no longer enough just to crank out work lists. We're going to be valued for not only interpreting images, but managing and helping the enterprise manage the role of imaging in a much more complex area. But it's not enough just to have high quality, you also have to have high efficiency. And that's difficult to do until you remember, if any of you have heard my talks earlier this week, that both efficiency and quality loathe the same enemy, and that is variability. Properly used, IT can help reduce that variability, and so that's kind of nice. So as I said, the real goal in radiology now is not just cranking through the work list, but helping the enterprise understand the role of imaging in a very complex environment. Into doing that, we have to be irreplaceable, but more importantly, it's not enough to do the right thing, we have to self-promote. We have to prove that we're doing the right thing. I know of no better way of self-promotion than using analytics, and that's the purpose of this talk. We have to be a differential value innovator, but the drive here is not scorecards and dashboards and all that. It's evidence or data-driven radiology. And that's what we're really trying to talk about when we're talking about BIA. And in order to do that, we have to have an enabling platform. And that enabling platform, I regard as a fully leveraged electronic-based workflow and practice management infrastructure that can support these requirements. The goal is measurable, with the emphasis on measurable improvements in efficiency and quality and all the other metrics that the enterprise cares about. The model generally approach in BIA is to model this against certain kind of metrics. We call those key performance indicators. We will identify and define that in a bit. So in my mind, my bias is that business intelligence analytics is the critical enabling tool for us to accomplish this. You've heard this old chestnut, you cannot improve a process unless one can measure a process. I used to believe that. It's pretty good most of the time. I actually don't believe that anymore. And we'll try to explain that if there's time. There probably won't be time, so we can talk about it afterward. So what's business intelligence analytics? It's more than what we think it is. It's more than our reports or scorecards or dashboards. Business intelligence analytics is not something you buy. It's something you do. It's something you are. It's your worldview, to be evidence-driven, to be data-driven. It requires a comprehensive strategic perspective with modeling, and as I said, it's not something you buy, it's not the widgets, it's not the presentation. Think data-driven or evidence-driven business intelligence. And unfortunately, we're 10 years behind other industries, so we think our dashboards and scorecards are really, the latest and greatest things. I just have to tell you, other industries don't use those anymore. Okay, because they're not useful in many ways to address modern requirements, and we'll talk about that in a bit. So what's the general business intelligence analytics approach? First, sounds kind of hokey, but first you have to have a vision of what your practice wants to be. What is it that you want? How many of you have a vision statement? How many of you think that's more like, mom and apple pie? We want world peace and everyone love each other, kumbaya. Yeah, the problem is vision statements are actually important because it defines your worldview and what you want to be in that world. And the first step in business intelligence is to extract goals that hopefully achieve your strategic vision. Once you do that, and this is the hard part, once you've defined those goals, you've got to figure out a strategy to achieve those goals. You have to define the appropriate business operational model. Now, it looks really neat and clean in a little PowerPoint presentation. This is really hard and dirty. And we'll get into how dirty that is in a bit. Once you've actually, by some miracle, have defined a meaningful business model, then you have to define metrics by which to judge whether or not you've achieved those goals. And that operational model is running optimally. And that's what we call the key performance indicators. And then once we've done that, then the other hard part is you got to call your IT and informatician, as Mark says, and says, okay, I have to have these metrics, but these metrics require us to extract data in black boxes that are very, very difficult to come by. And in the newer kinds of metrics require a polyglot or polymorphic extraction of information that resides in multiple sources, not just radiology controlled systems, but the EMR, billing, all sorts of things. And that's really difficult, which means you need to work with people like me in IT to generate all these kind of neat little widgets. And the most important thing is you got to do it all over again. And you got to keep doing it over and over and over again every single day, every single hour, which means you have to develop a sustainable, agile, sustainable governance model. Okay? That's the hard part. Like I said, if you remember anything in this rant, BIA is not something you buy, even though the vendors try to convince you of that. It is something you are, something you do. It's the way you see your practice. Evidence-driven workflow. Okay, so what is business intelligence analytics? We're not just several years behind. I think we're about a decade and a half behind other industries when it comes to leveraging business intelligence, which is a good thing. It's good to be a laggard position, because you don't have to recapitulate the errors of early adopters. You can leapfrog. It is a wonderful intellectual arbitrage opportunity. It is the best risk mitigation strategy I know. The problem is in radiology, we're very radiology-centric. In fact, most of our scorecards and dashboards basically derive from stuff that the risk knows and our PACS. That's pretty pathetic. And we're going to need more and more intelligent infrastructure to do that. The other thing I don't like about it is we're so 1990s in this. We talk about scorecards and dashboards, or originally retrospective scorecards. We're so behind in this, we don't even know the difference between a scorecard and dashboard. Here's a hint. 99% of the time when someone in a healthcare enterprise says, here's our dashboard, they're actually referring to a balanced scorecard. We don't even get our words right. Okay, and that's why people who are in other industries look at us, they go, oh my gosh, they're hopeless. Kind of scary. Now, I don't want to show this because this is how the rest of the world approaches BIA. We're not ready for this yet, all right? So let's just at least get our words right. Let's at least understand the difference between a dashboard and a scorecard, because every time I hear it, it's kind of embarrassing because every industry goes, these guys don't even know what a dashboard is. Like I said, 90% of the time when someone talks about a dashboard, they're actually referring to a balanced scorecard. So let's try to define these terms, or at least, even though this is 1990s technology, at least let's get it right. Okay, so what's a dashboard? Dashboards are actually relatively rare. That's why I find it astounding. Everyone talks about dashboards. They go, they're really hard to build. Trust me, I've built these things for years. Hard to build dashboards. Why? Because they tend to be, they're prospective, real-time, operational. The scope is tactical. Are we winning this particular knowledge work or task? Usually leverages certain, graphs, charts, doesn't really matter. The goal is data dimension reduction to provide tactical situational awareness. Scorecards are very different. They are strategic in scope. They're performance management tools. This is what your head administrator or your chair uses. Your section chiefs. These are strategic. Are we winning the war? Up, down. They're based on KPIs. They are retrospective by definition. They are data dimension tools to provide strategic situation awareness. Now that may be as clear as mud. Okay? So I'm going to give you a graphic example. By some incredible coincidence, amazing coincidence, the best example of a dashboard is a dashboard. Okay, it's amazing. Isn't that amazing? It has to be a god, right? Okay, what's a dashboard? Real time, prospective, for the knowledge worker. You are going 100 miles an hour. That might not be wise, okay? This is a dashboard. Tactical, real time, operational. Got it? The scorecard is the traffic ticket you get. All right? It's the report card. Okay, so here's a test. This is our EIA. We call it Enterprise Intelligence Analytics, but this is our BIA portal. This is report turnaround time for this radiologist, me, and so here's our KPI, and I'm pretty good. Is this a scorecard or a dashboard? This is a scorecard. How many of you refer to these as dashboards? Be honest. Yes, most of you do. Okay? Don't do that anymore. It's embarrassing. Okay? It's like saying diverticuli. Okay? Or saying incidence instead of prevalence, which is also 90% of the time people do that. Okay, so this is anything that's retrospective. I don't care what the scale time is. Last month, last week, last hour, scorecard. Okay? This is a dashboard. Real time. You're about to do something funny. There's something that has to be done. That's a dashboard. So let's use dashboard. So as a result, let's look at some examples. Dashboards in radiology are actually very rare. Okay, this is one that we developed. This is, everyone has a work list that prioritizes stats and ERs because that's what the RIS knows. Ours is a little different. In addition to doing that, it also says, hey, dictate this one first because this patient is scheduled to be discharged from the house for length of stay. That's a big win for us. This one is ready to be, this one is being seen in clinic in 2 hours. Get this report out, okay? This is real-time dashboard. I don't want a scorecard that says, oh, we negatively impacted throughput in the clinics or length of stay. You sucked, suck less. I don't know how to suck less. Here, I don't have to make decisions. It's helped me. It's on rails. Remember, the greatest source of variability is humans, okay? Unfortunately, in our industry, we require humans to instantiate business logic. Other industries do the opposite. So this is an example of a dashboard can help. I'm going to go past that one because I find that one insulting. Scorecards. Scorecards are aplenty. We all have scorecards. Unfortunately, most of them call them dashboards. We have our days in accounts receivable, our throughput, RVUs, average volumes, turnaround times. These are all scorecards, okay? You can actually do very sophisticated visualizations. Where's our leakage or CD-ROMs? Where are our CD-ROMs coming from? How come they're not getting our studies? All right, this is a leakage map that Bill Boone gave me on this. Is this a dashboard or a scorecard? Scorecard, okay? It is retrospective, it is strategic, it is not tactical, okay? Now I've just caught us up to 1990, okay? So what's the rest of the world do? They don't do that, and the reason for it is both scorecards and dashboards have a single strong assumption that frequently fails. They are designed to be consumed by people. What if I don't give a damn? What if they say, Chang, you sucked. Try to suck less next quarter. Well, I'm going to tell you, I'm a tenured full professor at the University of Chicago, so go to hell. Oh, you think that's rare? Okay, that happens a lot. I know your groups, you never have anyone like that. Okay, this is a problem. They depend on people to do the right thing, and this dependency can be a significant liability. I'm not going to finish this, so I'm going to skip all this for now. Complex event processing is what the real world does. They don't rely on people to instantiate workflow. Machines can instantiate workflow. Let people succeed. Don't make them fail. That's the key here, right? This is an example of what we've been developing. Instead of having a person figure out who has to drink, who needs to go to the scan, and get consent and drink contrast, let a machine do it. They can orchestrate it better, so you never get the wrong study and the wrong scanner, okay? And in addition to that, let's do predictive analytics. Instead of giving a scorecard that says, hey guys, you sucked last quarter, try to suck less, why don't you say, hey, you're about to suck. Please don't do that. Okay? And that's what predictive analytics is about, and I won't get into that. And now the big hype. Okay? I know this is the first session you've ever heard of big data and deep learning. I know, but trust me, a few people are kind of interested in this. Big hype. We've always had a big data problem. Always. We've always had a big data problem. We just now have some tools that might be able to handle it. Big data approaches, I don't want to get into this. We talked about this early this week for those geeks who in my talk on big data, NoSQL, and deep learning. The bottom line is one size doesn't fit all. We need to have polyglot and polymorphic solutions. And that's the key. The problem was always there. The difference is the rules of the game of healthcare reform have changed, so now we have to compete instead of just be good enough. And the second thing is we now have better IT tools. That's the only thing that's changed. So calm down on the hype. Here's an example of our big data deep learning problem in Chicago. Our big problem is we're terrible at following up incidental findings. And the reason is because the same thing I told you. It requires the radiologist, a human, to instantiate the process. I have to say, oh, this needs to be followed up. I have to, as Mark says, I have to look up at the right recommendation. I have to look at the risk factors. No, machines do that better. So this is what we have. we use deep learning to have an anatomic model, and so when I evoke a measuring tool, the system knows my cybernetic buddy is not replacing me, it's helping me. It's looking over my shoulder and says, hey, Chang just instantiated a tool that he only instantiates when he's measuring something discrete, and we're in the lung. Hey, guess what? Let's call that a nodule. Can I do something useful for my human buddy? Yeah, let me check to see if there's a risk factor, and let me check the latest selective requirements, and let me populate a database. Saves time, saves money, reduces variability. So what I'm thinking, while we're still talking about scorecards and dashboards and getting it mixed up, the rest of the world is thinking about this. They actually don't talk about business intelligence analytics that much anymore. They talk about data contextually driven human cybernetic collaborative workflow orchestration. It's the same thing. It's basically using, don't talk about replacing, let's augment, let's see what machines do well, and let's help machines set up humans to succeed rather than fail, which is the opposite of what we do. All right. How much time do I have? 2 minutes? 5 minutes? Oh, we might finish half of this. Okay, so now that you have the background, how do we do it? Okay, and unfortunately I won't have time to tell you how to do it, so haha. Anyway, no, actually, it's a pretty straightforward recipe. Okay, so the first thing is modeling. This is hard. You have to remember, you have your goals from your vision statement. Now you have to figure out what is your business. Because you can't define your metrics until you actually define what it is you're trying to measure. What is your business operational process? There are a lot of ways to do it. There's business method, formal business methods like BPM, business process modeling. Don't write this down. Here's the bottom line. The result of this is to come up with key performance indicators. What are metrics that actually reasonably and justifiably and realistically measure what we're trying to accomplish. Bottom line, we suck at this. We're bad at this. We're not trained to do this. Our administrators aren't trained to do this, even if they have an MBA. They're not good at this. This is one of the few places, I usually hate consultants, but this is one of the few places where consultants can very help. Now, where do you find these guys? How many are doing Kaizans and Lean and all that other stuff? All right, you've not done Kaizans and Leans? You've been spared that hype? I am jealous. Because Kaizans alone are like just rearranging the seats on the Titanic. I just never understood Kaizans. The same guys that cause variability, I'm going to get them together to solve the problem? That's rearranging the seat. No, I need a new Titanic. So don't get me wrong, I'm a big Toyo Lean fan, but Lean alone is insufficient because people can't solve problems alone. Because they are stuck by precedent. All right. So what you want is consultant services, but they're the same guys will tell you you need to augment all your lean processes also with technology. All right. That's a winning combination. Get consultation help for this. Once you've done that, then here comes the IT stuff, all right? Because obviously now we're going to define after we've defined our KPIs, now we have to figure out a way to extract information from all these places that don't share well and don't play well with each other. How do we get them all together? That's kind of hard because it's an issue, because these systems aren't designed to support analytics. And so you got to work with IT and informatics, as Mark said. All right? Now here's the problem. Most of these systems aren't very friendly, I said, getting stuff out, and I need it. Okay? I need it to do my stuff, so I'm stuck. How do you do it? Two basic strategies. I'll tell you how the rest of the world and how we do it, and how you're going to do it. Okay? I have given so many talks for the last decade on service-oriented architecture. I've given up trying to convince you guys, even though the rest of the world does it. And you refuse, okay, because it's a governance model. But here's basically the problem. Right now, we require humans as integrating agents, require humans to get all this information, okay? Whereas the rest of the world uses something like this. Now, the names have changed. It may not be service-oriented architecture. It may be REST. It may be microservices. It may be this new term, DevOps. I don't care. The key point is we don't require humans. If you want to get information from EMR, you don't have to use the EMR application. We normalize, extract information, and make it possible to mash up experiences. What do I mean by that? We all can do this. This is how 10 years ago when I went to Chicago, how I convinced my CIO to do this. I said, we're already doing this, we're just not doing it at scale. So, first thing, we have our systems. Every one of you have someone that you call Mary, Joe, or Larry that by some magical trick will get you your monthly crystal report. Yeah? You all have that, right? So here's what the SOA approach is. Okay, I'll take Mary, Joe, and Larry, and instead of doing it just to support one report, tell me your trick. We call that the ETL, extract, transfer, load. How do you get from these systems? Is it a SQL call, DICOM query, HL7? I don't care. What are your tricks? And instead of just doing to feed me one fish, teach me how to fish. Normalize those not into a report, but normalize into something I can reuse. I say XML now. I know most of us use JSON now. I don't care. This is like the Xerox term, all right? We're basically turning it into a self-describing schema, and then you combine that with a way that I can extract it and mash stuff up. This is how the rest of the world works. There's differences in details. They may not call it SOA. They may call it microservices, REST. I don't care. But this is the way the rest of the world works. All right? And I figured I'm a big believer in intellectual arbitrage. This is the way we do it. This is the way you get the information for your scorecards and dashboards, complex event processing, and feature big data. Okay? That's not how you're going to do it. I've tried for 10 years begging you to do this, but the problem is because it is not something you buy. It is a cultural change. It is governance. It is hard for IT to change. All right? So here's how you're going to do it and how most people. You can go right now in the technical exhibit and find 10, 15 vendors that do this. They're going to do exactly the same thing, but they're going to put it in a box for you. Because we IT people, we're good about standing stuff up, plugging it in, and supporting it. Okay, SOA requires governance, semantic normalization, committees. Scary. Okay, buy it, put it in our data center or in the cloud, support it. Okay, and that's what it is. This is an appliance that does the same thing. So this is how you're going to do feed your analytics. Now there's some challenges here. I don't have time to get into it, but you got it. This is very hard. Semantic normalization is difficult. Once you've done that, then you can buy something. Then you buy something that gives you your pretty widgets, your pretty little presentations, and your visualization. This you can buy, okay? There's some design considerations we don't have time about because you're going to buy this anyway. So whatever you think is pretty or effective, or you want to do your Tableau stuff, I don't care because that's the least important thing. Unfortunately, most people think that's the thing that they think that's business intelligence analytics, something you buy, a box that gives you pretty pictures, okay? That's the least part of this process. So do you build or buy? Obviously the answer is both. It's not something you buy, it's something you actually are. You use your resources. You actually collaborate with IT. The most important part of BIA is you have to do this over and over again every day. So governance is critical. I'm a big believer in lean and Toyota method, so everyone should be able to pull the chain in the assembly line. So this is what we do at Chicago. Everyone, a medical student, technologist, secretary, administrator, everyone can pull the chain by going into our SharePoint BIA project Intech and say, I've got a problem. I have too much variability. Can analytics and business intelligence save the problem? We're not asking them to solve the problem. We're asking just describe the problem in a paragraph. You know, we're not asking you to tell you should it be a scorecard, dashboard, complex event processing tool. No, we'll do that. But it gives us a chance to complete the loop and build this. So you tell me report timeline sucks, we'll build you this. Okay? But you need to have, or BIA portal, you need to have a sustainable infrastructure. So in closure, the suggestions. You want to start modestly, you have to start, but you want to exploit leapfrog opportunities. Being in a laggard position is advantageous because you can do intellectual arbitrage. It's a great risk mitigation strategy. This is the only thing you have, well, in addition to dashboard, scorecard, don't make that mistake. This is the only thing you have to remember in this talk. BIA is not something you buy, it's something you are. It's something you do every day. You have to adopt an enterprise, not radiology-centric perspective. This is a team sport, guys. You cannot do it in a radiology-centric, have a radiology-centric bias. You have to close, continuous collaboration with all stakeholders. And thank you very much. I was only, a couple minutes over line, so here we go. Thanks very much.
All right. Good morning, everyone. My name is Benjamin Strong, and I'll be talking about the optimal radiology workflow. Oops, sorry. A quick bio on me. And by the way, I love seeing Dr. Chang speak. I've seen him a number of times. It's probably not as fun to follow him, though, huh? Quick bio on me. I actually am the Chief Medical Officer at VRAD. We're the largest practice of radiology in the country. I personally have double board certification in both internal medicine and radiology, and I did a fellowship in MSK and body MRI, as well as having worked for 3 years as an ER doctor. What I'm going to talk about is essentially the lessons we have learned in building an integrated workflow for our radiologists. And I'm a little more nuts and bolts as far as this goes. I hope that you will take from this some basic principles and strategies that you can run home and apply tomorrow. We have actually spent, we estimate, about $60 million, and it has taken 15 years to build what we have. I know that most people do not have access to that kind of funding or that kind of time, but all the same, please look for the underlying principles and strategies that you can in fact apply right away. So this was a picture my wife took of me on my last day of fellowship. And you might think I'm smiling perhaps because it's my last day of fellowship. Maybe I'm smiling because I have all that hair. But in fact, I'm smiling because I know it's my last day in front of an alternator. I absolutely despise those things. This was our workflow back then. We had order creation that was effectively a tech filling out a form by hand. We had study distribution that was a tech stacking films on my desk. We had report creation that was talking into a transcriptionist and then signing it after perhaps a 24-hour delay. And then in the shadows on the wall, there's a phone with perhaps a dog-eared piece of paper with the important phone numbers for me to call should I have a clinical communication to make. So there is no accounting for triaging studies, prioritizing them in any way. There's no special handling of specific study types. There is no operations center to facilitate your communications. There's no report formatting, structuring. There's no control of report content from one radiologist to the next, and there's no ability to apply analytics and learn lessons from the actions of the past. So what did we do? In radiology, we went digital, or so we thought. And in fact, all we did is replace each segment in the radiology workflow with an application. But in fact, we did not make any efforts to customize or adjust those applications to our particular needs, and we made no effort to integrate them one with the other. So this is a common problem. When people go from an analog to a digital workflow, the most common issue cited is that they simply try to duplicate their pre-existing analog workflow. So what we have done is actually, first of all, turbocharge each of these segments. And we've done so by applying widely available applications. And these are general categories, not specific applications. We use visual recognition algorithms to sort and triage our studies. We use natural language processing to real-time assess the content of our reports. We use, of course, voice recognition, but with an exceptional, highly developed strategy that I'll demonstrate. And we use an automated dialer in order to facilitate our clinical communications. The other thing we've done, which is probably just as important, is we have integrated these segments one with the next. And if you're wondering what are those gray arrows and how do I get some, they're basically just this: information. We are passing information from the point of order creation through every segment of this workflow. Therefore, we are introducing efficiencies, we are eliminating redundant entry, and we're reducing the potential for error. So bringing it all together by that passage of information will make this one nice, tight workflow. So let's talk about where they come from. Dr. Chang did a wonderful job with this, and I have just brief comments on them. Most of our information will come from one of these sources: HL7 interfaces, DICOM headers, and our own order management system. So these are things within your grasp. The HL7 interface, the DICOM header, you have control of these at some level. So here are the things you need in order creation, just as basic categories. You need patient demographics, you need details on the procedure you're performing, and you need a decent clinical history. So our system is essentially this: we take information from the HL7, we take information from the DICOM header, we feed it into an order management system that populates the various fields for that procedure that we know we need information in, and then we require the technologist to fill in any gaps as they create that order. The reason we have to do it that way is we don't have access to the HL7, to the DICOM headers. You do. So it's something that I don't see people taking advantage of. So by doing this, we can get the basic patient demographics. Further, from the HL7 interface, we get procedure descriptions and additional study details. We also get payer information. Now, the HL7 interface can be configured. The fields of information that are passed into your system can be identified and mapped. It is sometimes a little bit of a struggle. You have to deal with governance, you have to deal with committees, you have to deal with IT restrictions and regulations, and it can sometimes be expensive. Ultimately, though, this information, you all must agree, is very valuable, and it is ultimately helpful to pursue that. Now, even easier and closer within your grasp is the DICOM header. The DICOM header is a textual entity that comes along with every image set. And we held out great hopes for this, because if you look at some DICOM headers, they're flush with information. But as we look at over 2,000 facilities that we work with around the country, it turns out they're all over the map. There is so much variation in how DICOM information is passed, how it's formatted, and whether or not it's even present. We built crawlers to look through all the DICOM header information that we were receiving in our image sets, and specifically dealing with CT. And we actually found we did pretty well with reformatted images, reconstructed images. We can identify those series and pass that information right into our radiologist report without them dictating. On the other hand, it trends down to as low as 10% for some of these things: radiation dose, contrast type, and dose, which is abysmal. And it really, ultimately, it comes back to the facilities. When you implement a new modality, the vendor generally is doing the configuration of the DICOM header, and they're putting in things at random. That header can be reconfigured. You can dictate to your vendor the fields you want populated, the format that it's put in, and you can actually access this information in an automated fashion. And again, that 10% just simply tells me this is underutilized. Lastly, we have an order management system where our technologists actually fill in the gaps. And the thing that I would emphasize about this is just emphasizing logic. In whatever you build, in whatever technologist entry you have, make it logical. You cannot go into our system and order a CTA without providing the contrast dose and type. You cannot order an ultrasound study without indicating the presence and specific location of an ultrasound worksheet. You cannot order a nuclear medicine study without giving us the tracer type, the dose, and the timing. That's pretty simple stuff, but most systems actually allow any of those things to happen. Lastly, the clinical history. We actually welcomed the ICD-10 initiative and took this as an opportunity to actually develop a system that would encourage our technologists and ordering physicians to give us a more robust clinical history. What we did is simply build nested serial pull-down menus into which the clinical history can be entered, and they are logical, with each following pull-down menu being informed by the answer given for the preceding. So when a technologist orders a CT of the abdomen, they're presented with an appropriate list of symptoms. When they pick that symptom, they're asked to localize it. Then they're asked to give further information about the chronicity and any underlying important clinical data. And we pull that all together and create a single human-readable sentence for the clinical history that is then passed into all of our reports. So no radiologist in our practice ever dictates study information. Those days of saying CT of the abdomen from the diaphragm to the pubic symphysis with oral and intravenous contrast, coronal and sagittal reformats, reconstructions, delayed images, and a prior study compared to dated this and that, that information is all pulled in and automatically populates our reports. All right, so that's the important beginning, which is the order creation. Now, a few quick words about workflow and the work list itself. These are the parameters in the lower half of the slide that our algorithms take into account as they distribute studies. Now, some of them obviously are accessible to you. Many of them are based on the fact that we're a very high volume emergent practice. But you can see we take into account obviously state license, facility credentials, hard and soft specialty match. We even have determined the frequency with which any given procedure has a critical finding, and we prioritize those that have that greater likelihood. All of these add up to, however, a few basic principles as far as a work list goes. One is we do tiered distributions. We first send it to the 3 most appropriate radiologists. As time goes on, we send it to larger and larger numbers. That way we can limit to a reasonable length the length of every radiologist's work list, and we can limit the number of readers that a given site sees on any given night. And this keeps us from overwhelming our local caching and has all kinds of other advantages. So that's one principle I think is worth applying in your work list. The other one are these 2 simple rules. First of all, by all the criteria that I just showed, you can tell every radiologist is different. They all have a different credentialing and licensing profile. Therefore, every radiologist's work list is different. However, these work lists are not silos. The studies on a given radiologist's work list are not just exclusively available to that radiologist. Each case on every work list is present on multiple other radiologists' work lists. You can tell that by the fact that we are doing multiple distributions. And the net effect of that is that our radiologists do not feel queue pressure. And that is something I think is worth offloading from your radiologist. It's a horrible phenomenon. You give someone 20 studies and they know they're the only one that can access them, they are going to read faster because poor guy number 20 isn't getting read until 1 through 19 are. And that's really the kind of thing that can encourage people to work beyond their capabilities. So our work list, as you sit and watch it, is quite dynamic. Even if you didn't open a study, you would see studies disappearing from it, studies appearing on it. Right? We can further prioritize studies, so when we get one designated as a stroke study, it automatically jumps the queue. And we always bundle studies together when they come from the same patient. So those are a few principles I think worth trying to apply in whatever study distribution system you're using. The bottom line is this: you do not want it to be a silo, and you do not want it to be a cat herding free-for-all. If you give radiologists the opportunity to just open any old study, they'll all open the hand films, they'll ignore the emergent studies, and they'll certainly skip the lumbar spine MRIs on women named Ethel, Rose, or Mabel. Lastly, you just can't allow cherry picking. I believe firmly, after 15 years in radiology practice administration, there is nothing that kills the morale of a practice faster than allowing people to game the system and to jump around on the work list. And it flies in the face of all the efforts you're making to otherwise prioritize these studies and get them read in an expedited fashion. So, no cherry picking. Let's next talk quickly about study triage. We actually do use visual recognition algorithms that have been built for us by some young and hungry startup third parties. We basically take every non-contrast head CT we receive, we run it through a dedicated server that runs this algorithm and flags it either as positive or negative for acute intracranial hemorrhage. And then we just built some simple rules into our work list distribution so that any non-contrast head CT flagged by that algorithm is immediately distributed to all the available radiologists, circumventing all the distribution rules I previously described. So this is one you may not be able to build in an automated fashion, but it's worth taking into account the basic principles here. We have a protocol system where when a technologist is requesting a radiologist recommendation for a protocol on a given study type, they send in that question. It appears on our work list as a study. We typically turn these around in less than 2 minutes. The radiologist opens it up, reads the question, and simply types an answer. Once that goes back to the technologist and the images are created, those images then are routed to the same radiologist. So think about those 2 things where most practices do not accomplish the goal. We do not document, typically, a radiologist's recommendation for a protocol, and they do not typically go back to the radiologist reliably who made that protocol recommendation. So we've learned to treat a few other study types specially, and this is mostly through operational adjustments. The stroke protocol is one. That comes in, obviously, at a reduced turnaround time. It jumps the queue as well, as I previously indicated. But we have also tied it to operational processes. Most stroke centers want to be called. They either want to be called right when the study's open, they want to be called right when the study has been read, but in many cases there is a stroke team standing there waiting. Some sites even have asked that we call on all studies, positive or negative. Some just want calls on the positive. In any case, we can build that in, and you see the highlighted region up here, critical test call initiated. So when a radiologist opens a stroke study, they're immediately alerted, and that is tied to our automated dialer, which automatically dials the phone number for that referring clinician or that stroke team. Now here's my truth in advertising slide. This is what our actual system looks like when we open a case page. This is a mock-up that shows the same information fields. So the other interesting protocol we developed is trauma. We had a problem with traumas in that they were coming in with a head, orbit, face, C-spine, chest, abdomen, pelvis, T-spine, L-spine, and we were bundling them all to one radiologist because we liked that idea, that continuity of care. It turns out you do that, you're going to create a 1-hour turnaround time by the time that last study is read. So we have simply divided the trauma studies. When they are designated as a trauma study by the sending site, we divide it at the clavicles and trunk, and essentially send everything above the clavicles to one radiologist, everything chest, abdomen, pelvis, T-spine, L-spine to another radiologist, and then the extremity studies to a third. And every one of those radiologists gets a warning to the effect that other radiologists are involved in interpreting other body parts on that patient. All right, the operations center, this is simple enough. They simply facilitate all the tasks that our radiologists might request, and we just have a button right there on the screen where you click, and you're presented with a menu of the most common tasks that are requested. Anything that dropped through the cracks in our order intake, any informational elements that are missing, you just click that button to request it, send it off to the operations center. They pursue that task to completion, and then they designate that case on your work list as the next case to read. So the radiologist never has to sit there wringing his hands and thinking, where is that? Have they done it yet? Right? When it's done, you know it will reappear on the list. All right, here is the real meat of things as far as I'm concerned. Voice recognition is not used correctly anywhere. There are a lot of ways that you can apply this kind of program, and I don't see the kind of innovation or strategizing around it that I really believe there should be. So I will show you our evolution through the use of voice recognition, show you the pitfalls with which I'm sure you're familiar, and then show you the overriding strategy that we apply that honestly has addressed them all. So typically, the first time you're handed voice recognition, you kind of unimaginatively just talk to it, right? You set down the transcriptionist microphone, you pick up the dictation microphone for your voice rec, and you continue to mumble at lightning pace with a mouthful of potato chips and figure you can torture this thing just like you used to your transcriptionist. So you grab it and you say, there is no evidence of acute intracranial hemorrhage. And what you get is garbage. It drops nose, it gives you intercranial instead of intracranial, it gives you windage instead of hemorrhage, it gives you urine instead of period. That one's happened to me about 1 million times. I still can't figure it out. They don't sound anything alike, but there it is. The bottom line is this is a terrible way to use voice recognition. Nobody's going to create whole reports. At the error rates that even the vendors cite, you will be getting several errors in every report you send out. Now, we have done two things that I think were incredibly helpful, and these date back many years for us at this point. We made it so that when you speak directly to the voice recognition system and are dependent on that word-by-word recognition, that text is read. That allows you to spot where you need to do your most vigilant editing. That's where you know that you are at risk. The other thing we did is we actually culled The dictionary in our voice recognition program, it had over 20,000 words, and we pulled about 15% out that could never possibly have a medical application. So we removed words like windage and yeoman and tuna and engine, and that had an enormous impact. And that was something, honestly, we just did manually, and it's the kind of thing that anyone can do. Ultimately, again, you don't want to use this approach, but it is your default. Ultimately, we are going to be doing pre-configured single statements as we read a study, but you will encounter things, multi-organ tumors, multiloculated abscesses that defy any kind of pre-configured description, and at that point, you do just default to talking to it. We estimate that a good, experienced user in our system talks to the system about 5% of all the text that they submit. So for all those reasons, this is not the primary approach. Now, the first thing you do when you realize you can make a macro, right? I can just attach a trigger phrase to a whole paragraph, a whole normal report, and God, I'm practically done. I'll go home early and rich. The problem here, of course, is that these are always going to need to be adjusted, edited. So what I'll do in this situation is I'll talk to it. There is interpeduncular density consistent with acute subarachnoid hemorrhage. So I get my red text statement, and I'm so pleased I made that subtle finding, but we know, of course, what the problem is with these. There is this line up here. There is no evidence of acute intracranial hemorrhage, directly contradictory. And the only way you're going to find that is if you, A, have every macro memorized, or B, vigilantly reread every single macro every single time. And neither of those is a reasonable expectation. So what's going to happen is you're going to sign that, it's going out, and the person who reads it doesn't know the difference between a macro and a direct statement, and he sees two directly contradictory things and doesn't know what to make of your report. He also thinks you're kind of stupid. The other problem with this is you have to go up here and actually select this. And that will be a laborious thing, picking that out of a block of text, and it will cause you to drop your mouse and hit your keyboard. And that's one of the cardinal sins of workflow as far as we're concerned. Touching your keyboard, taking your eyes off the diagnostic images are both absolute no-nos. So, for all those reasons, this is not the way to go. Now, the next evolution we did is we said, okay, why don't we take our macros and make them so there is only one statement per line. Now it's easier for me to spot that potentially contradictory statement. It's easier for me to select that for editing purposes because I can triple click on any given line and select it. So if I wanted to alter one line, I would just triple click it and then dictate over it. Click white minimal. And I can drop a single sentence macro in place of that line. So then I go on, think, oh, what other findings were there? Oh, there was sinusitis. So I highlight that line, click right maxillary sinusitis, and drop a new line in. So we're getting there. We're getting there, but we still have the risk of sending out an inaccurate statement. There's no better way to send out a gallbladder is normal statement in a patient with cholecystectomy than to take this pre-configured approach. So the other issue is that this will cause you a great deal of angst, right? You'll be reading it and then you'll get down to the orbits and you'll start thinking, oh geez, did I look at the orbits? I think I looked at the orbits. I always look at the orbits. Why wouldn't I have looked at the orbits? I better look at the orbits again. And you start bobbing your head back and forth between the two screens as though you're watching a tennis tournament. So for all those reasons, this is also not the way to go. So here is how we actually do it. We do it one line at a time with our eyes on the diagnostic images. We have a macro library of 2,700 of the most commonly uttered radiologic sentences, all tied to trigger phrases. Click no atrophy. Click white minimal. Click ventricles. Click no ischemic. Click no hemorrhage. Click skull. Click right maxillary sinusitis. Click orbits. Click extracranial. This is now a travel log. It's a real-time documentation of your progress through that search pattern for that procedure. You have no reason to question the accuracy of any of those statements. You have no need for editing. You're not even having to put in any kind of punctuation. So the next thing to talk on is structured reporting, and I'm running out of time, so I'm going to race ahead a little bit. But what our structured reporting does is essentially categorize each one of these statements and just drops them into the appropriate category. Now, that's nice in that it gives a uniform appearance to our reports, but what we also do is cull the content of these reports. It will give you warnings if you have failed to include diction that's required for reimbursement. It will give you warnings if you fail to include compliance statements, left-right laterality conflicts, inappropriate gender statements. It will provide you with links for reference if you're describing a certain type of finding, and it will give site-specific recommendations. So that is pretty much it. The last thing I'd show you is that we are just basically, we tie this to critical findings. So our system will identify critical findings and will initiate the call through our auto dialer as previously described. So we get a note that says Dr. Smith calling on patient Jones. We click it and it relaunches the report and the images for the patient under discussion. All right, so that is our rundown of optimal radiology workflow. Greatly appreciate your attention and like to introduce Dr. Hawkins, who is next with social media.
Okay, well, certainly a privilege to be here with you all to talk about a topic that's, I think, quite different from maybe what's been presented here previously. I'm going to spend a little bit of time talking about social media with you all. For those I haven't been able to meet, I am on faculty down at Emory in Atlanta. So first thing I like to do when I talk about social media, I want to start out by making you all a promise, and that promise is that I will not claim that social media is going to fix all things and completely transform the world as we know it. But I want you all to promise me as well that you'll acknowledge that social media is more than pictures of food or your favorite moments from the Taylor Swift concert. And I think if we all can agree on that, we'll make more progress here. Most importantly, as we talk about social media, and the number one most important thing, social media is not about technology. This is not high tech. Social media is about changing the way that people communicate, and in our case, our patients communicate. I could stop the talk right here. Why is social media important? Okay, but in an era of electronic health records where patients have access to their radiology reports through patient portals, patients will absolutely Google you. I'm a pediatric interventional radiologist by training. All of my patients' parents are my age. When I come into clinic, they know everything about me. They know where I went to medical school. They know I trained at Cincinnati Children's. They know I've been to the University of Washington in Seattle. They can tell it all from the beginning. So how many in this room have Googled themselves? Okay, good. Got a lot of liars out there, though. Those that didn't raise your hands. If you have not Googled yourself, I would encourage you to do this. I can't speak intelligently about how Google bots work and how they prioritize the search results that will show up on Google. But this is, not that long ago, I went ahead and Googled my name, Matt Hawkins, MD. And these are some of the things. This is the page one search results. LinkedIn. Google loves LinkedIn. If you have a LinkedIn profile, it will show up on page one. My Doximity profile shows up as well in the top 10 search results. Twitter profile also is there. And why is this important? It's because the content that patients find about me when they search me online is what I've chosen to populate there. I get to curate what the content is that patients find when they search me out. Now, the one I haven't figured out, there's old Matthew T. Hawkins, a sports medicine physician out of California. Somehow he snuck in there on the top 10 search results. Why is page one important? Over 90% of all clicks on Google are on page one. So even if you do have some content out there that's on page two of Google, patients are not going to find you there. So if you want to create and own the content that patients are going to find out about you, social media is a great way to do that. We studied this down at Emory. So we Googled every single radiologist in the United States of America. So if you're a U.S. radiologist, congratulations, you were part of the study. We appreciate that. One of our residents who's brilliant actually built a Google Autobot that Googled every single radiologist's name and then populated the website root of the top 10 search results. And no surprise, over 70%, as you can see here, of all physician websites, when you Google your name, are third-party physician rating sites. That's Health Grades, that's Vitals, and other sites like that. So again, by using social media, you can displace the third-party websites where you have much less control over the content that is there and take ownership of what patients will find. If you do not believe that patients will Google you, I'm going to give you a couple of examples. This is straight off of my Twitter feed. This is a couple of years ago. Patient's father. Matt, do you treat vascular malformations? If so, I have an 8-year-old son in Roswell, Georgia that needs a procedure. Thank you. I have now, of course, taken care of their son. This was out of nowhere, unprompted. How about this one? For people that are part of Facebook, you know they have a lot of patient groups out there. I'm blown away by the granularity of some of these patient groups. This is actually the person who runs the orbital lymphatic malformation patient group. That's a real thing, believe it or not. And she had reached out to me she came down from Indiana. She had reached out to me through Facebook. And then after we took care of her son, she posted this in the Facebook patient advocacy group. Do you think the number of orbital lymphatic malformations I have taken care of since this went up has increased or decreased? You can figure that out, okay? So patients are on these websites. Patients are using social media. They're using these platforms to communicate in ways that they've never done before. The other important thing that social media allows you to do as a physician is really curate the content that you want to put out there, okay? The concept is patients are on the internet. I'm still surprised this is only 85%. I do wonder what the other 15% are doing. 72% now are using the internet to search for healthcare information. 24% now are posting about their health. I think this is a very important concept. People think social media is violating privacy. I cannot go on my Facebook page anymore without seeing somebody posting about a healthcare issue or disease process that they're battling through, about their child, about themselves, about their mother. 15, 20 years ago, when the HIPAA era came out, people didn't talk about their health. That's completely changed now. 24% are posting about their health. That number is only climbing. Where it might get really interesting for physicians is now over 25% of people are posting reviews about their health care, right? This is Yelp for doctors. They are now going and posting, and patients are looking at these reviews and using them to influence how they consume health care. Why is that important? In this era now where information is so readily available and people seek out not only information about a product or a physician, but also reviews about a product and physician, it changes because of this concept called pre-commerce. I don't know if people are familiar with this. Bob Pearson wrote a book called Pre-Commerce probably about 6 or 7 years ago. But the best way I can describe it is how we purchase cars now. Think about how we bought cars 30 years ago. Usually you went down to the car dealership. It was probably a weekend like Memorial Day or Labor Day where they're having a big sale. You walked into the lot. The car salesman or saleswoman walked up to you and started showing you cars. You said, yeah, this is kind of nice. Maybe I'll take it for a test drive. You took it for a test drive, and then that was your first interaction with that brand or that product, okay? Well, how do we do it now? You look up everything about what the car is. You look at consumer reports for their safety ratings. You can go to Kelley Blue Book and see what that is selling for, not only in the country, but in your geographic district. You can go to get a Carfax report if it's a used car. You know what you're going to buy before you walk onto that lot. You have interacted with that product long before you actually physically touched it or looked at it on a car lot. Who's bought something on Amazon? Who looked at a review of a product on Amazon? Who let that influence their purchase? That is pre-commerce. So this is the next slide is the most important slide of this entire presentation. We have to accept this. Our patients have already formed an opinion about us before we meet them. That first moment in the clinic, that moment we talk to them after when we're giving them results about an imaging study, they already have an opinion about us. And we need to understand that's what social media does. It's not the technology, it changes the way people communicate and seek information. Going into other benefits of social media besides just being discoverable and controlling the content that patients can find, it's an incredible resource. For me personally, I find it incredibly fruitful and am blown away year after year at some of the relationships and people that I've been able to meet through social media. So who's on social media? Patients. Patients are very, very active on social media. They want our opinion. They want to interact with us in ways that they interact with other people in their lives. Patient advocacy groups. You can make a really big impact if you can reach out to some of these patient advocacy groups, particularly if you're a physician that takes care of patients in those groups. Health policy experts. When you look at macro and all the healthcare legislation that's come through recently, the influencers, maybe not the people who wrote that 2,000 pages or whatever macro was, but the influencers who shaped that legislation, they are on social media and they are willing to interact. You can reach out to them. You can at least read their stuff and follow what they're thinking. I want to introduce the concept of hashtags. I do think it's important. I think now most people are familiar with what a hashtag is, but basically it makes social media content something that's mineable. There's so much content on your Twitter feed and on your Facebook page that a lot of social media moments, if you don't make the content mineable, just become lost in the ephemeral abyss of social media. But now with hashtags, you are able to search content on social media based on topic, not on who you follow. We're always focused on friends and followers and contacts and connections. That's how social media networks were originally constructed. But now you can use social media, you can search social media for content. And that's a really important concept. So these are a couple of the hashtags. If you're not familiar with, I would encourage everyone to pay attention to. If you are a breast imager, you really should be following the BCSM hashtag, okay? Incredible patient and physician conversations going on with that hashtag. Lung cancer social media, LCSM, one of the most ragingly successful hashtags that has started a patient movement and really helped drive through some of the lung cancer screening coverage that we have been facing as a specialty. Okay, so the concept of searching content rather than just people, I think, is a very important one. This is how hashtags work. This was me searching hashtag BCSM. Again, that's breast cancer social media on my Twitter feed. So even if I don't follow these people, anybody who's posting about breast cancer social media, I get to see the content that they're searching, or that they're posting, excuse me. So very important concept. It really has changed what social media can be used for. Rather than just following people, you can follow topics and content. We've tried to organize how we approach social media content in radiology. And actually, with the help of 20-some-odd folks about a couple of years ago, including patients and physicians, we tried to construct a radiology hashtag ontology. The point of this is so that 10, 15 years from now, we can go back and actually look at what we were talking about within certain topics. I think it will be very interesting 15 years from now to go back and look and see what people were saying about gadolinium toxicity in the brain. I think it would be interesting if you follow the PEDSRAD hashtag up there on your upper left. What we were saying about radiation, particularly 20, 30 years from now, it will be very interesting to see what we were saying about radiation in children. The interventional radiology hashtag, IRAD, become very successful. It's actually cultivated a really strong social media community within the interventional radiology subspecialty. If we use this and tag our content appropriately, now that data becomes mineable. It becomes meaningful. It's not just about that moment. Meeting hashtags are a great example. You've probably been following the RSNA 16 hashtag. Most meetings have them now. The stuff that people are talking about with those hashtags is way more valuable than any post-meeting evaluation form that you are going to fill out. You actually see what people are paying attention to, what sessions were the most popular, etc. So hashtags are a very powerful way to make social media content usable and meaningful. There's other great data you can get from social media. So it turns out we are being followed. For those concerned about privacy, there is no privacy. I'd encourage you to get over that. So there are 889. There are actually private entities out there that track this for healthcare analytics. They're currently tracking about 900 U.S. radiologists. This data is a couple months old, so I'm sure that's bigger now. They know that radiologists in the United States send out about 500 tweets per day, and that the average doc tweets about once per day. They know this and obviously can do some density mapping like this. We're on par actually with some of the other subspecialties. 947 ER docs are on Twitter. Over 1,300 pediatricians are on social media. I think that is a reflection again of the parents of their patients. They're our age, they're on social media, they're seeking them out, and so social media carries perhaps a more important importance with that population. Other fun stuff you can do with social media. This is actually a map of every physician-to-physician interaction from RSNA 2015. Size of the node is with the number of people that you connected with. But what's cool about this is just for show. I mean, who cares what doctors are talking to each other at RSNA? But now if you take this and you look at the LCSM lung cancer social media hashtag, you can see who's talking to each other about that. Is that patients talking to patients? Is that patients talking to physicians? Physicians reaching out to patients? Healthcare policy experts reaching out to patients? When you can start seeing who's interacting over certain topics, it's going to open up possibilities that we can't even at this point begin to imagine. So to close, the ultimate question, why should physician leaders, why should physicians have an online social presence? One, be discoverable and make sure that information that patients find about you is what you want them to find out about you. Control your personal brand by populating page 1 of Google in a meaningful way. Help your patients by providing information that's actually going to be helpful for them. And then ultimately, build your own personal information network. Final plea, if you still don't believe me that social media can make an impact, this is a case example from Dr. Harry Jha, who's a radiologist at Penn and a prolific writer. Wrote a post on kevinmd.com, which is one of the most widely read healthcare blogs in the United States, because he was annoyed with the overuse or perhaps improper use of point-of-care ultrasound in the emergency department. Very well written. Immediately after this is within a month of that post coming out, the American College of Emergency Physicians Ultrasound Group issued a statement that point-of-care ultrasound is not an extension of the physical exam. Beyond that, this website, EMRes, is a gathering place that provides a lot of education for emergency medicine radiology residents. This is straight off of the website. In a response to an article on KevinMD, in this article, Dr. Jha, and he goes on to talk about that. So Harry actually instigated a conversation within the emergency medicine community because of social media. Lastly, some of you might have read this, of course, when ProPublica came out with their surgeon scorecard in New York. Harry wrote another excellent piece. What jumps out at you on the screen? 15,000 shares off of KevinMD alone. That does not include the number of posts on Facebook. That does not include the number of retweets on Twitter or posts on LinkedIn. I have told my chair, Dr. Meltzer, over and over again, no matter how amazing of a peer review article I write, it will never come close to being shared by 15,000 people. So you can carry a lot of influence via social media. So with that, I thank you all very, very much for your time.
We don't really have a whole lot of time for questions, but there were 2 questions from our virtual meeting, and I wanted to try to address these. The first one was said, regarding my biopsies, how did you conform with privacy issues? And basically, I have a treating relationship with all of those patients, and so I have access to that data, and there really aren't any particular HIPAA issues surrounding that information because I'm taking care of that patient. And then another person on the virtual meeting asked, is it time to develop an ACR standard for clinical and technical information on the DICOM header? That's kind of interesting because the ACR isn't really involved in the specification of what should and shouldn't be in the DICOM header. That's actually the DICOM standards committees, and the DICOM standards committees have to have some type of variability in the standards so that people can innovate and put in things that haven't been thought of. And so what we really need to do is we need to continue looking at the ways that these vendors have been innovative and take those things and add them into the public tags in the DICOM header. And if there are any other questions in the room, we'd be happy to chat for a second. Thank you very much for your time and attention today.